Welcome to KEKS Construction Engineering. Most building failures don't happen because of bad materials, they happen because of bad interpretation of drawings. Today, I'm going to show you how to read beam reinforcement drawings like a pro and execute them correctly on site so that your building will not be at risk. By the end of this tutorial, you will learn how to read, interpret, and execute this type of structural beam drawing correctly on site. Now, let's start with beam 01. Beam 01 is a continuous beam of 2 span. Take note of the distance between the grid lines B, C, and E as we proceed to represent it on site. We are clearly using a step-by-step 3D animation to read and represent every single rebar on the beam detailed drawing. Therefore, pay attention as we proceed. Stop struggling with structural beam blueprints. Follow this detailed guide to the end to master everything you need to know about blueprint reading and on-site execution. Pouring of the supports B, C, and E. Formwork removal. Having completed the construction of beam 01 supports, let's start reading, interpretation, and implementation of the beam drawing. Let's start with the bottom bars. This means that we're to provide two pieces of 16 mm bars across the both span. Hence, add the total span length and the development length at both ends. Now, let's execute it practically on site. This is the 2 pieces of 16 mm bars required the bottom. From the drawing, we are to use 8 mm mild steel as stirrup with 135-degree hook. The letter arrow represents mild steel. Let's fix the first stirrup and then tie this to bottom bars to it. Let's read and interpret the top bars. You can also get this detail from section 1 to section 4. This means that we are to provide two pieces of 16 mm bars across the both span. Hence, add the total span length and the development length at both ends. This is how to interpret beam top bars T1 on site. Let's fix them carefully and tie them to the first stirrup. From the drawing, let's read and note the various numbers and spacing of the stirrups. This means that we are going to provide 10 numbers of stirrups at 225 mm spacing, 7 numbers at 150 mm spacing, and 11 numbers at 225 mm spacing respectively. This is how to interpret it on site. 10 numbers of stirrups provided at 225 mm center-to-center spacing. 7 numbers of stirrups provided at 150 mm center-to-center spacing. As you can see, the stirrups at support C are placed closer to each other at 150 mm center-to-center compared to the stirrups at the span. This is to resist maximum shear force at the support. 11 numbers of stirrups provided at 225 mm center-to-center spacing. Now, let's check details of extra bottom and top bars so we can interpret them accordingly. This green bar below is used to indicate the extra bottom bars required to balance the positive bending moment at the bottom. From this drawing, it's to numbers of 16 mm diameter bars. You can also see this bar details in section 424 below. This is how to interpret and execute extra bottom bars on site. At the end of this reinforcement placement, I will show you why it's very important to interpret and place these bars correctly, and the failure that may occur if interpreted and placed wrongly. Now, let's check details of extra top bars so we can interpret and place them accordingly. This extra top bars are provided to balance the negative bending or hogging moment at the support. You can use the designed length above, or use your local code, or determine the length using the L/for rule. To get the actual length of this extra top bar using the L/for rule, divide each of the effective span connecting to the support C by 4 and sum them with the thickness of the support. From the drawing, provide two numbers of 12 mm diameter bars for the second layer extra top bars T2. See how they are placed. You can confirm this bars with section 2 and 3 of the drawing. Now that we have completed the beam reinforcement, let's place 25 mm concrete cover so we can lower the beam rebar cage onto the formwork. Now, let me show you why it's very important to interpret and place these top and bottom bars correctly. Tension forces are maximum at the mid-span, thereby causing the mid-span to experience high sagging or positive bending moment. That's why extra bottom bars are provided at the mid-span to balance these tension forces. If you wrongly interpret and place these bars, your structure will fail like this. In the same manner, compression forces are maximum at the support, thereby causing the support to experience high hogging or negative bending moment. That's why extra top bars are provided at the support to balance this negative moment. If you wrongly interpret and place these bars, your structure will fail like this. Also take note, to ensure maximum structural integrity, you should lap top bars at the mid-span center of the beam and bottom bars near the supports columns where the respective tension forces are at their lowest. Now, let's construct formwork for the beam so we can pour concrete. Ensure you do proper inspection of the rebars before covering it fully with formwork. Ensure proper bracing to avoid bursting of formwork. Pouring of concrete beam. Formwork removal. I upload construction videos here every week. Yes, there are many construction videos on this channel. Go ahead and ask whatever you don't understand. I always reply, thanks. Ensure the concrete beam has attained its maximum strength before removing the bottom formwork. Good job! We have completely read, interpreted, and executed Beam 01 detailed drawing. Before we move to Beam 02, if you have any question, drop it in the comment. I will reply you. Do let me know if you want me to do more of this kind of detailed construction video. In this Beam 02, I am not going to spend much time on it so that this video will not be prolonged. Read the drawing carefully and follow the step-by-step site execution of the beam blueprint. Feel free to ask me what you don't understand. Setting and pouring of Beam 02 supports. Formwork removal. Placing of 25 mm concrete cover. Fixing of the first bottom bar, B1, 2, numbers of 16 mm diameter bars. Fixing of the first top bars T1 to numbers of 16 mm diameter bars. 13 numbers of stirrups links at 225 mm center-to-center spacing. 12 numbers of stirrups links at 100 mm center-to-center spacing. 8 numbers of stirrups links at 225 mm center-to-center spacing. Fixing of the second layer bottom bars B2 to numbers of 16 mm diameter bars. Using the L/4 rule for curtailment to determine the length of extra top bar. Fixing of extra top bar to resist negative or hogging moment at the support. Fixing of the second layer top bar T2 to resist negative or hogging moment at the support. In a case where there are more than 2 extra top bar at the second layer of the support, you can use short bars like this or smaller stirrups to tie and hold them in place. Always make reference to the beam structural drawings to ensure strict compliance. Now that we have completed reading and fixing all the beam rebars, let's complete the beam formwork so we can pour the concrete beam accordingly. Brace the formwork properly to avoid bursting during concrete pouring. Pouring and vibrating of concrete beam to avoid honeycomb. Formwork removal. Yes, we have been able to fully demonstrate how to read, interpret, and execute beam blueprint in this tutorial. Let me know if you need more of this detailed tutorials. I upload construction videos here every week. Yes, there are many construction videos on this channel. Go ahead and ask whatever you don't understand. I always reply, thanks. Thanks for watching.